Good afternoon. On behalf of the program committee, it is a pleasure to welcome you to San Francisco and to the 2019 meeting of the Cognitive Neuroscience Society. Of course, San Francisco is a beautiful city in which to have this meeting, and I hope that at some point, perhaps over the lunch breaks or the coffee breaks, you'll have a chance to step outside of the conference walls and actually enjoy some of what the city has on offer. San Francisco is also a city that is known for its bridges, and so I always find it apt that it is a city that we come back to so often for these CNS meetings. Because of course, CNS really is a society that is about bridging different approaches toward understanding human thought, about integrating the psychological, the computational, and the neuroscientific approaches. It's also a society that's about bridging continents, bringing together scientists from around the world who seek to challenge one another, to invest in one another's ideas, and to push each other to rigorously test their hypotheses. And I know that since the time that I was a graduate student and first started coming to these meetings, I've really appreciated that CNS is also a society that tries to bridge scientific generations. It brings together trainees, those that are brand new to the field or perhaps still figuring out if this is the field of study for them, and it puts them in contact with the founders of the field, with people that have made seminal contributions to the study of human thought. And so again, I think it's really fantastic to keep in mind these bridges that we're forming here in the beautiful city of San Francisco. The interdisciplinary approach was certainly on full display earlier today for those of you who were able to attend the outstanding Data Blitz talks by our trainees and to see the wide array of fabulous research being conducted in the poster session. And later today, the panel discussion on the relation between psychology and neuroscience will once again zoom in on the benefits and also the challenges of trying to integrate across psychological and neuroscientific approaches. So with this in mind, it's especially exciting to introduce Dr. Matthew Walker as this afternoon's keynote speaker. Dr. Walker is professor of neuroscience and psychology at the University of California at Berkeley. He's also the founder and director of the Center for Human Sleep Science. He earned a degree in neuroscience from Nottingham University in the UK, and his PhD in neurophysiology from the Medical Research Council in London. And prior to beginning his professorship at Berkeley, he held faculty appointment at Harvard Medical School. Dr. Walker's research team really does embrace this integrative approach toward research, investigating the role of sleep using brain imaging methods, including MRI and PET scanning, high-density EEG recordings of sleep, genomics, autonomic physiology, brain stimulation, cognitive testing. They bring all of this together in order to try to understand the importance of sleep for our everyday life. Now, his website actually states that his research team's motivating goal is working toward understanding, quote, everything about sleep's impact on the human being, from birth to death, in health and in sickness. So that's a gargantuan task, but certainly he's up to it, and he's chipping away at it, building this understanding piece by piece. To date, he's published over 100 scientific research studies, and the wide reach of his research into the effects of sleep really becomes apparent when you read and look at the scope of his writings. So just a few examples include a Nature Neuroscience article on the sleep-deprived human brain, a Neuron paper titled Sleep and Human Aging, and an article in the Annual Review of Clinical Psychology on the role of sleep in emotional brain function. So he clearly appreciates the need to bring together a lifespan developmental approach, an affective and social approach, and a cognitive approach to really understand the impact of sleep. Furthermore, as I think he'll discuss this afternoon, he also really sees the importance of understanding the connections between the brain and the body, and leveraging those complex interactions to fully understand the importance for sleep in our waking lives. Dr. Walker is widely recognized for his research, having received funding from the National Science Foundation, the National Institutes of Health. He's a Kavli Fellow of the National Academy of Sciences. He's also been featured on many television and radio shows, including CBS 60 Minutes, the National Geographic Channel, and the BBC. He's a sleep scientist at Google, and he served as an industry consultant to many companies. So in this regard, Dr. Walker really embodies the spirit of this public lecture, insofar as he firmly believes that scientific discoveries should not stay hidden in the pages of scientific journals, but should be shared broadly and communicated clearly to all stakeholders. And of course, when it comes to understanding the importance of sleep, the stakeholders are many, all of us in this room, and the stakes are incredibly high. He does a compelling job outlining these stakes in his best-selling book, Why We Sleep, and I expect that he'll be sharing many of these insights with us this afternoon. Now, as a sleep researcher, Dr. Walker may be among the precious few speakers who may not become offended if you doze off during his talk this afternoon. But I predict that this is actually going to be a riveting talk that is going to keep you awake, engaged, and learning throughout. So even if you're feeling some jet lag, perhaps save that nap for after his talk when you can consolidate all that you've learned. It is really a distinct pleasure to welcome Dr. Matthew Walker to the podium to give us his answer to the question, why sleep?
Well, it is a delight and a privilege to be speaking with you, and thank you to Elizabeth for such a wonderfully kind introduction. I don't know if I will match up to the expectation. I'm also very humbled by the number of people from the general public who've come along to listen to the talk as well, so thank you for that. With all of that said, I would like to start with testicles. Men who sleep 5 hours a night have significantly smaller testicles than those who sleep 7 hours or more. In addition, men who routinely sleep just 4 to 5 hours a night will have a level of testosterone which is that of someone 10 years their senior. So a lack of sleep will age a man by a decade in terms of that critical aspect of wellness and virility. And we see equivalent impairments in female reproductive health caused by a lack of sleep. This is the best news that I have for you today. From this point forward, it's only going to get worse. I'm also going to tell you about the alarmingly bad things that happen when you don't get enough, both for your brain and for your body. Let me start with the brain and the functions of learning and memory. Because what we've discovered over the past 10 or 15 years is that you need sleep after learning to essentially hit the save button on those new memories so that you don't forget. So sleep will actually future-proof that information within your brain. But recently we've discovered that you not only need sleep after learning, you also need sleep before learning. And now to actually prepare your brain almost like a dry sponge ready to initially soak up new information. And without sleep, the memory circuits of the brain essentially become waterlogged, as it were, and you can't absorb new memories. Let me show you the data here. So here in this study, we decided to test the hypothesis that pulling the all-nighter was a good idea. So we took a group of healthy adults and we assigned them to one of two experimental groups, a sleep group and a sleep deprivation group. Now the sleep group, they're going to get a full 8 hours of shut-eye, but the deprivation group, we're going to keep them awake in the laboratory under full supervision. There's no naps, there's no caffeine, by the way. It's miserable for everyone involved. And then the next day, we're going to place those participants inside an MRI scanner. And we're going to have them try and learn a whole list of new facts as we're taking snapshots of brain activity. And then we're going to test them to see how effective that learning has been. And that's what you're looking at here on the vertical axis, the efficiency of learning. So the higher up you are, the more that you learn. And when you put those two groups head to head, what you find is a quite significant 40% deficit in the ability of the brain to make new memories without sleep. I think this should be frightening considering what we know is happening to sleep in our education populations right now. Just to frame that in context, it would be the difference between acing an exam and failing it miserably, 40%. And we've gone on to discover what actually goes wrong within the brain to produce these types of learning disabilities. And there's a structure that sits on the left and the right side of your brain called the hippocampus. And you could think of the hippocampus like the informational inbox of your brain, in that it's very good at receiving new memory files and then holding on to them. And when we looked at this structure in those people who'd had a full night of sleep, we saw lots of healthy learning-related activity. Yet in those people who were sleep-deprived, we actually couldn't find any significant signal whatsoever. So it was almost as though sleep deprivation had shut down the memory inbox, and any new incoming files, they were just being bounced. You couldn't effectively commit new experiences to memory. And if you'd like to know what life is like, by the way, without a functioning hippocampus, just watch the movie Memento. I'm sure lots of you have seen it. This gentleman suffers brain damage. And from that point forward, he can no longer make any new memories. He's what we call densely amnesic. The part of his brain that was damaged was the hippocampus. And it is the very same structure that sleep deprivation will attack and block your brain's capacity for new learning. So that's the bad that happens if I take sleep away. But let me just come back to the control group for a second. Do you remember those folks that got a full 8 hours of sleep? Well, we can ask a very different question here. What is it about the physiological quality of your sleep when you do get it that restores and enhances your memory and learning ability each and every day? And by placing electrodes all over the head, what we've discovered is that there are big, powerful brainwaves that happen during the very deepest stages of sleep that have riding on top of them these spectacular bursts of electrical activity called sleep spindles. And it's the combined quality of these deep sleep brainwaves that act almost like a file transfer mechanism at night, shifting memories from a short-term vulnerable reservoir to a more permanent long-term storage site within the brain that prevents you from forgetting. And it is important that we understand what it is during sleep, mechanistically, that is actually transacting these memory benefits, because there are real medical and societal implications. And let me just tell you about 2 areas that we've moved this work out into. I'll start with medicine, and specifically the topic of aging and dementia. Because I think many of us have a sense that as we get older, our learning and memory abilities begin to fade and decline. It's harder to learn, it's harder to recall and retain. But what we've also known for a long time is that a physiological signature of aging is that your sleep gets worse. And not just any type of sleep, by the way, especially that deep quality of sleep that I was just discussing. And only last year, we finally published evidence that these 2 things are not simply co-occurring. They are significantly interrelated. And it may suggest that the disruption of deep sleep is an underappreciated factor that is contributing to what we call cognitive decline or memory decline in aging, and most recently we've discovered in Alzheimer's disease as well. Now, I know all of that is remarkably depressing news. It's in the mail, it's coming at you if it's not already there. But there's a possible silver lining here, because unlike many of the other factors that we know are associated with aging and dementia, for example, changes in the physical structure of the brain, or even changes in the blood flow dynamics of the brain, those are fiendishly difficult to treat. And medicine has no good wholesale approaches right now. But that sleep is a missing piece in the explanatory puzzle of aging and Alzheimer's is exciting because we may be able to do something about it. And one way that we are approaching this at my sleep center is not by using sleeping pills. Unfortunately, they are blunt instruments that do not produce naturalistic sleep, and they have been associated with a significantly higher risk of death as well as cancer. And I'm happy to speak about that evidence during the Q&A. Instead, we're actually developing a method based on this. It's called direct current brain stimulation. It sounds a little bit like science fiction, but it's actually science fact. You apply electrode pads to the head, and you insert a small amount of voltage into the brain. So small that you may not even feel it, but it has a measurable impact. Now, if you apply this stimulation during sleep in young, healthy adults, as if you're sort of singing in time with those deep sleep brainwaves, not only can you amplify the size of those deep sleep brainwaves, but in doing so, you can almost double the amount of memory benefit that you get from sleep. The question now is whether we can translate this same affordable, potentially portable piece of technology into older adults and those with dementia. Could we restore back some healthy quality of deep sleep? And in doing so, can we maybe salvage aspects of their learning and memory function? That is my real hope now. That's one of our sort of moonshot goals, as it were. So, by the way, I always get asked the question, people say, where can I buy one of those devices? I want one yesterday, I want 5 more tomorrow. They are not yet FDA approved for sleep. You can buy them online. I strongly advise against that. You can just go onto YouTube. People have misaligned the voltage, the skin burns, they've lost their eyesight for several days. Don't do this. We are desperately trying to bring this to fruition as soon as possible. So that's sleep and memory in medicine in the context of aging. But let me now speak about sleep and memory in society. Because if sleep truly is so essential for learning, then increasing it in a context where it matters most, such as education, should prove transformative. And it has. Because there are several school systems throughout the United States that have begun to delay their start times so that kids can sleep longer. And then they've looked at the academic outcome. One of the earliest test case examples happened in Minnesota. And they shifted their school start times from 7:25 in the morning to 8:30 in the morning. And then, by the way, what are we doing trying to educate our next generation at 7:25 in the morning? To give you a sense of that, school buses for a 7:25 start time maybe start leaving at 5:30 in the morning. That means that some kids may be waking up at 5:15, 5 o'clock, even earlier. This is lunacy. But here in Minnesota, it was the beginnings of a movement. And the measure that they looked at was actually this. It's called SAT scores. This is, for those who don't know, this is a standard university entrance exam here in the United States. And in the year before they made the time change, when kids were going to school at 7:25 in the morning, the average SAT score was 1,288. Now, that turns out to be a respectable score. The following year, when kids were going to school at 8:30 in the morning and getting more sleep, the average SAT score was 1,500. That is a 212-point increase, which is non-trivial. That may change which tier of university those kids go to, and ultimately, perhaps, their subsequent life trajectory. Now, some people have questioned aspects of the Minnesota study, and I think for good reason. But in all of the carefully controlled reports to date, the findings are unequivocal. Academic grades increase, behavioral problems decrease, truancy rates decrease, and psychological and psychiatric referrals also decrease. But something else happened in this story of later school start times, and it was something that we did not anticipate. The life expectancy of students actually increased. And you may be thinking, I don't understand, how is that possible? The leading cause of death in late-stage adolescent teens in most developed nations is not suicide. That's actually second. It's this: road traffic accidents. And here, sleep matters enormously. So another example comes from Teton County in Wyoming. They shifted their school start times from 7:35 to 8:55. And the only thing that was more remarkable than the extra 1 hour of sleep that those kids reported getting was this: There was, as a consequence that following year, if I can get it to work again, there was a 70% reduction in vehicle accidents that following year. Just to put this in context for you as they're bringing this down, the advent of ABS technology in cars, anti-lock brake systems that prevent your wheels from locking up under hard braking so you can still maneuver, that dropped accident rates by about 20 to 25%, and it was deemed a revolution. Well, here is a simple biological factor, getting enough sleep, that will drop accident rates by up to 70%. I think we need to radically reconsider the importance of sleep in education. Because when sleep is abundant, minds flourish. And if our goal as educators truly is to educate and not risk lives in the process, then I fear that we are failing our children in a quite spectacular manner with this incessant model of early school start times. So that's sleep for learning, memory, aging, Alzheimer's, education. What else is sleep good for? Let me tell you that sleep is essential to help stabilize, and I'm sorry, it's completely stopped now, so I don't quite know. Next slide. Okay, thank you very much. Sleep is essential to actually help stabilize your emotional and mental health. And without sleep, the emotional circuits of your brain can become hyperactive and irrational. Allow me to demonstrate with a sleep-deprived subject. Next slide. Because it turns out that we do video diaries with our participants throughout the deprivation night. And you're going to meet one under the pseudonym of Jeff. Jeff has just entered the study. It's 11:30 at night on day one. He's been awake for a perfectly normal 16 hours. And let's hear from Jeff what his sort of hopes and aspirations are for the deprivation period. Next slide.
Hello. It's about 11:27 right now. I've been here for about I think about an hour. No. Yeah, about an hour. So it's the first hour. I'm writing my paper right now, 30-page paper. Hopefully I can get some of it done before I get too sleepy.
So that's Jeff, a perfectly likable, affable chap who's hoping to get his 30-page report complete in a night of sleep deprivation. Classic delusional undergraduate thinking, I have to say. I see it all of the time in my students. So sorry, now let me fast forward the clock. It's now 5:30 the following morning. Jeff has now been awake for 22 hours straight, and instantly you'll notice one of the hallmark features of sleep deprivation, which is that you actually slide down in your chair. Jeff, just look around the room right now. Jeff is down about 6 inches here now. It's about an inch for every hour that you've been awake beyond a standard 16, based on our highly sophisticated machine learning algorithms. But in all honesty, notice just how emotionally different Jeff has become. And some people have rather unkindly described him as becoming a little bit emotionally unhinged. So let's hear from Jeff how that 30-page report has been going. And I do apologize ahead of time for the profanity.
Hello. I'm very angry right now because I didn't get any fucking. But can I curse on this? I think whatever. They probably think I'm crazy. I'm very lucid actually.
So did you notice how Jeff went from being remarkably upset and annoyed that he got none of his 30-page report complete to then finding it almost hilarious? He was almost sort of punch-drunk, giddy on sleep deprivation, and then came right back down to baseline again. That is a remarkably abnormal emotional distance to travel within such a short time period. And I think it emphasizes the type of destabilizing influence that a lack of sleep has on our emotional integrity. And we've gone on to discover what actually changes within the brain to produce this type of pendulum-like emotional irrationality. And there's a structure that sits very deep within the brain. Next slide.
Hello.
Next slide. Called the amygdala. And you can see it here in the red colors. And the amygdala is one of the centerpiece regions for the generation of emotional reactions, including negative reactions. And when we looked at this structure in those people who'd had a full night of sleep, next slide, here in green, we saw a nice, controlled, modest degree of reactivity. Yet in those people who were sleep deprived, we saw this amplified, almost aggravated degree of responsivity. In fact, the amygdala was almost 60% more reactive under conditions of a lack of sleep. It's almost as though without sleep we become all emotional accelerator pedal and too little regulatory control brake, as it were. But what was more concerning, perhaps, to us was that this represented a neurological signature that was not dissimilar to several psychiatric conditions. Next slide. And we've gone on to discover links between sleep disruption and disorders such as depression, anxiety, including PTSD, schizophrenia, and tragically and most recently, suicide as well. In fact, over the last 20 years, we have not been able to discover a single psychiatric condition in which sleep is normal. So I think sleep may have a significant story to tell in both our understanding, our treatment, maybe even ultimately contributing to our prevention of grave mental illness. That's another one of our hopes as well. So that's sleep for your brain, but of course sleep is just as essential for your body. And here I could have gone into any one of the model systems in detail. We've already spoken a little bit about sleep and the reproductive system. Or I could tell you about sleep loss and your cardiovascular system, and that all it takes is 1 hour. Because there is a global experiment that is performed on 1.6 billion people across 70 countries twice a year. And it's called daylight savings time. Now, in the spring, when we lose 1 hour of sleep, we see a subsequent 24% increase in heart attacks the following day. In the autumn, in the fall, when we gain an hour of sleep, we see a delightful 21% reduction in heart attacks. That's how fragile and vulnerable our bodies are to even just the smallest perturbation of sleep. I think many of us would think nothing about losing an hour of sleep. But as a deeper dive, I would like to focus on this sleep loss and your immune system. Next slide. And here I want to introduce these delightful blue elements in the image. Next slide. They are called natural killer cells. And you can think of natural killer cells like the Secret Service agents of your immune system. They are very good at identifying dangerous foreign elements and eliminating them. What they're doing here is embedding themselves into a malignant, a cancerous tumor mass and destroying it. So what you want is a virile set of these immune assassins at all times. And sadly, that's what you don't have if you're not sleeping enough. Next slide. So here in this study, we're not going to deprive you of sleep for an entire night. You're simply going to have your sleep restricted to 4 hours for one single night. And then we're going to look to see what is the % reduction in immune cell activity that you suffer. And it's not small. It's not 10%, next slide. It's not 20%. In fact, what we see is a 70% reduction in natural killer cell activity. That is perhaps a concerning state of immune deficiency, and it happens essentially after one short night of sleep. Imagine the state of your immune system after months, if not years, of insufficient sleep. And it should come as no surprise then to learn that we are now discovering significant links between short sleep duration and your risk for the development of numerous forms of cancer. Currently, that list includes cancer of the bowel, cancer of the prostate, and cancer of the breast. In fact, the link between a lack of sleep and cancer has now become so strong that recently the World Health Organization decided to classify any form of nighttime shift work as a probable carcinogen. In other words, jobs that may induce cancer because of a disruption of your sleep-wake rhythms. So you may have heard of that old maxim that you can sleep when you're dead. Well, I'm being quite serious now. It is mortally unwise advice. Because if you adopt that mindset, we know from the data that you will be both dead sooner and the quality of that now shorter life will be significantly worse. This is what epidemiological studies teach us across millions of individuals. The shorter your sleep, the shorter your life. Short sleep predicts all-cause mortality. And the challenging news keeps coming, because if you are fighting a battle against cancer and not getting sufficient sleep, that cancer may grow more quickly and aggressively. So here I want to focus work not from my own sleep center, but that of a scientist called David Gozal, who works at the University of Chicago. And he looks at the relationship between sleep loss and cancer in mice. Now, I know this type of work isn't necessarily for everyone, and I will tell you when to look away at the time that's right if you would prefer to do so. But in one of the studies, he took a group of mice, and he inoculated them with some cancer cells on the back. And then he gave that cancer a 1-month period to grow. And at the end of the 1 month, he resected the skin, and then he measured the size of the tumor mass. Now, half of the mice were allowed to sleep normally during that 1-month gestation period. The other half had their sleep restricted, not total deprivation, just limiting their sleep a little bit, morning and evening. So I'm going to show you a video that describes the results, and now would be the time to look away if you would prefer to do so. So here you can see David pointing to a monitor with a mouse on the screen, and you can see the skin resected there, and you can see that tumor mass quite clearly. This is in one of the mice that was allowed to sleep normally during that 1-month period. In a second, I'll play the video, and he will reveal behind it another mouse, and that mouse was in the sleep restriction group. And you will see the difference. This is the difference. There was a 200% increase in the size and the speed of that cancerous growth caused by insufficient sleep. Worse still, the cancer in those underslept mice had actually metastasized. Now, that's just a medical description, meaning that the cancer had breached the original origin and started to invade other areas, organ, bone, as well as brain. And it's when cancer becomes metastatic that we see mortality rates escalate. So if you are fighting a battle against cancer and not getting sufficient sleep, it may be the equivalent of placing gasoline on an already aggressive fire. Sleep loss acts like an accelerant. And we now know that it produces a harmful biological fertilizer for the more rampant and rapid growth of cancer. Now, if increasing your risk for the development of Alzheimer's disease or cancer were not sufficiently disquieting, we have since discovered that a lack of sleep will even erode the very fabric of biological life itself, your DNA genetic code. So here in this study, again, you're not going to have your sleep deprived for an entire night. They took a group of healthy adults and limited them to 6 hours of sleep, next slide, for 1 week. And then they measured the change in the gene activity profile relative to when those very same subjects were getting a full 8 hours of sleep. And there were 2 critical findings. Next slide. The first was that a sizable and significant, next slide, 711 genes were distorted in their activity, caused by a lack of sleep. And by the way, that lack of sleep is relevant. We know that almost 1 out of every 2 adults in developed nations is trying to survive on 6 hours of sleep or less during the week. The second result was that about, next slide, half of those genes were actually increased in their activity caused by a lack of sleep. The other half were actually decreased. Those genes that were actually switched off or downregulated as a consequence of a lack of sleep, next slide, were numerous genes associated with your immune system, which again fits very well with the data I was just describing. Even here at a genetic level, you can see that immune deficiency. Those genes that were actually upregulated, or what we call overexpressed, next slide, were genes that were associated with the promotion of tumors, genes that were associated with long-term chronic inflammation within your body, and finally, genes that were associated with stress and, as a consequence, cardiovascular disease. Now, I think many individuals in society feel uncomfortable, next slide, about the idea of genetically modified embryos or even genetically modified food. But by choosing to get insufficient sleep, I think we may be forced to accept that we are performing a similar genetic manipulation on ourselves. And if we don't let our children get the sleep that they so desperately need, then we may be inflicting an unwitting, similar genetic engineering experiment on them as well. There is simply no aspect of your wellness that can retreat at the sign of sleep deprivation and get away unscathed. It's a little bit like a broken water pipe in your home, in that sleep loss will leak down into every nook and cranny of your physiology, even tampering with the very DNA nucleic alphabet that spells out your daily health narrative. So where does this leave us then? What is the piece of mental furniture, next slide, that I would like to gift to you as we finish this talk? Well, it would be this. Sleep, unfortunately, is not an optional lifestyle luxury. Next slide. Sleep is a non-negotiable biological necessity. It is a life support system. And it is Mother Nature's best effort yet at immortality. I believe it is now time for us to reclaim our right to a full night of sleep, and without embarrassment or that terrible stigma of laziness. And in doing so, we may finally be reunited with that most powerful elixir of life, the Swiss Army knife of health, as it were. And with that soapbox rant over, I will simply say good night, good luck, and above all, I do hope you sleep well. Thank you very much indeed. Thank you. Thank you very much. I'm more than happy to take questions. I think we have plenty of time. There are microphones, I think, in either side of the runway. It's not a runway, it's a footway. Yes, please.
Hello.
Hi.
Marvelous talk. Thank you so much, first of all. I was wondering about the upper limit of the sleep. So we're now sure that when it's shorter, our life is shorter. What about longer than 8 hours sleep?
Yeah, it's a good question. I think so. The question is about how long is maybe too long for sleep. Is there such a thing as too much sleep? There is a condition called hypersomnia, where we typically see that in people with depression. Now, if you look at that data, it's not clear that those people are actually sleeping longer. If you look at the results and you dig into them, people seem to be staying in bed longer, so therefore it may be masquerading as what we call hypersomnia. So that's unclear. But let's just kind of go with your idea, for example. Could there be such a thing as too much sleep? I actually think, yes, there could. But don't make any mistake about it. It's the same for the three other critical ingredients of life, which is food, water, and oxygen. Can you get too much oxygen? Yes, you can, and you can actually have free radical damage with hyperoxemia. Can you overeat? Yes, we of course know that too. Can you actually take on board too much water? It happened in the 1990s with the ecstasy craze, where people were drinking too much. They increased their blood pressure so much that they had cardiovascular, stroke, and heart attacks. So can you get too much sleep? Well, we haven't really discovered such a thing yet, but I believe there probably is. I suspect it follows exactly the same U-shaped curve law. Are most people in danger of getting too much sleep? Au contraire.
Great. Yeah, thanks. Amazing talk. So I had a question about the Minnesota data. So you presented improvements in SAT scores, which I think I can understand why just sleeping more would improve your health and learning, but typically SAT prep and those sorts of like what's on the test is not usually taught in schools. So I was curious why you presented on that and not maybe they also saw improvements in academic achievement on the test they're taking in school, not necessarily the SAT, which obviously people may care more about. But you would think if it's about learning the things that you get during the school day, then it would be also the grades.
Yeah, another great question. So that data is there. So if you look at general academic performance of classes in school, you see the same data that when you shift school start times, those grade point averages also increase. What's also interesting, however, is where that grade point increase for the in-class, in-school data is coming from. They're not changing their performance in the afternoon classes. Those grades actually stayed the same. Where are they improving? It's in the morning hours. That's where you see the spike, and it's an astronomical spike because it's sort of, when you average it out across the day, it's still significant. But where it's happening most is in the early morning hours. And I think for two reasons. Firstly, because they're getting more sleep, so the brain is just more capable overall. But also, the second thing is that they're just half asleep. They are not biologically designed, especially teenagers at that time of morning, to be absorbing any information, certainly let alone have any good grace. Having a teenager awake at 7 o'clock in the morning is like having, an adult awake at 4 o'clock in the morning or 5 o'clock in the morning. No, you wouldn't be the best form of yourself, would you, at 4 o'clock in the morning? Well, teenagers aren't either at 7 o'clock. Thank you. Yeah.
So I wanted to ask the flip side of the question that why we sleep. Why don't we sleep? I mean, it seems relevant because you want to. Something's preventing us from doing this. It's manifestly good for us. So.
It is, and it's a great question because, strangely enough, human beings are the only species that deliberately deprive themselves of sleep for no apparent gain. But when you actually assess why we are not sleeping, it turns out that there isn't one single answer. There's a whole constellation of different factors that have come to almost like a perfect storm in modernity. The first is that we're working longer hours. The second is that typically we're commuting for longer, which together means that people are leaving the house earlier and arriving home later. When they come home, they typically don't want to sacrifice television time or family time. So the one thing that gets squeezed like vice grips in the middle of the night is this gelatinous mass called an 8-hour night of sleep. But that's not the only problem. The next issue is that we've got things such as anxiety, which is a trigger of insomnia. We've never seen higher rates of insomnia than we have right now. And in part, that's underlied or undergirded by this spike that we're seeing in anxiety disorders. The next thing is an increased use of sleep aids, such as alcohol. Alcohol is anything but a sleep aid. It is a disaster for sleep, but people are using it as an over-the-counter remedy for their insomnia, which makes their sleep worse. Finally, well, not finally, but there are other reasons. Caffeine is now the second most traded commodity on the surface of the planet after oil, and caffeine is no friend of sleep. If you look at the astronomical rise in the number of Starbucks coffee houses over the past 50 years, and I've plotted this from the Financial Times, that tells you everything about why we perhaps aren't sleeping necessarily so good either. I think we are wired and tired in this generation too. Finally, sleep has an image problem. It has a stigma associated with it, which is what I described. And people now have almost this sleep machismo attitude. Some people do, not all, but some people do. Sort of a braggadocio of how little sleep that we're getting. And a lot of people will come to me at the end of talks and they will wait and they will shamefully say to me, look, I'm one of those people who need 8 hours of sleep a night. So I think the societal forces, I think there are pragmatic forces, I think there are chemical forces, all of which have come to a collision that are causing this great sleep depression. And it is, 1942, the average American was sleeping 7.9 hours a night. Now that number is down to 6 hours and 31 minutes.
Well, I'm happy to blame Starbucks. Thanks.
Can taking naps ameliorate these psychological and physiological effects of sleep deprivation?
So naps don't seem to be able to necessarily ameliorate the deficits. Can naps give you some benefits, though? And the answer is yes, and we've done a number of studies looking at this, that naps can sometimes give you almost as much benefit for things like learning and memory as a full night of sleep. I would say, though, that two things. Firstly, the naps that we use are not really power naps. They're usually 90-minute naps because we try to get a full cycle of sleep, and a human sleep cycle is about 90 minutes. So it's probably a little bit different to what most people use. The second issue with naps is that they're a double-edged sword. And when you are awake during the day, you're building up something called sleep pressure, and it's a chemical in your brain called adenosine. The longer that you're awake, the more of that chemical that builds up, the sleepier you feel. After about 16 hours of building up that adenosine, that sleep pressure, you should be able to fall asleep and stay asleep. And when we sleep, we remove that chemical, that adenosine. So we release the pressure valve on the cooker, and we sort of clear it away, and we wake up refreshed. So the danger with naps is that if you take them, or if you take them too late in the day, you actually take away, you relieve that pressure valve, and you release some of that healthy sleepiness that you've been building up. And then when it comes time to fall asleep in the evening, you either can't fall asleep or stay asleep. So the advice is, if you're struggling with sleep, don't nap. Or if you can't nap regularly, you probably shouldn't nap either. But do naps provide a physiological benefit? Yes, they do. But are naps like the bank, where you can sort of, accumulate a little bit of credit and then spend it off when you're going to face the debt? And the answer is no. Unfortunately, sleep is not like the bank, where you can't accumulate a debt and then spend it off at a later point in time. Thanks. You're welcome.
First, I wanted to say thank you for being on your soapbox. Your TED Talk changed my life for the better, and I make all of my students watch it, regardless of what course they're in or how much they care.
Thank you so much. Thank you.
But my question is, how can we dissociate the effects of sleep from what we're doing that is causing us not to sleep? So Jeff was getting very anxious about not writing this paper. Whatever the experimenters were doing to keep the mice sleep deprived, there's that interaction of whatever that is must be a stressor as well.
Yeah, I think that's actually a very good point, which is how do you disambiguate the detriment of continued wakefulness from the absence of sleep? Now, that sounds sort of a bit confusing and tautological, but it's actually not. It's exactly what you're saying, which is, are the deficits that you see by way of a lack of sleep, are they the deficits due to being awake longer, or are they the deficits due to the absence of sleep? And the way that we try to approach that is by then turning the tables and giving sleep back, measuring the physiological quality of sleep, and then saying, is there something about the quality of sleep that is predicting the benefit that you get? And then we can say, is the benefit that you're getting, which is predicted by your sleep quality, the same thing that it becomes impaired or is detrimentally impacted by the absence of sleep whilst you're awake? So we try to bootstrap that question by saying, yes, it could be just because you're awake, but if something in your sleep is also beneficially enhancing that thing, and that same thing is detrimentally impaired when you take sleep away, it's more than likely sleep dependent rather than wake or prolonged wake dependent. So it's sometimes a bit hard to get the scalpel in between those two, but there's ways of doing it. In the animal studies, it's much easier because you can do things like you can adrenalectomize the animals. You can take away the complete stress axis. You can supplement them with cortisol so they stay alive. And therefore, any of the deficits that you see there can't be accounted for by just things like stress or the biology that comes with insufficient sleep and stress. So you can sort of try to pattern match all of these things together, and finally, when you bring them together, that gives you a holistic view of whether or not something truly is sleep dependent.
Thank you.
Sure.
Okay, great talk. Ironically, I think it was a real wake-up call. What I wanted to ask you about, and you sort of left it open in your talk, is about sleep medication. What effects that have, if you can say something general about that. So I learned about that in my undergrad a long time ago. Quality of sleep is maybe not as good, but I also wondered if you could comment on the evolution of sleep medication. If you know anything about how they've gotten better, are there things on the market now that are not as bad as the ones they used to have, or if the whole thing is terrible?
Yeah, so the drugs that we have right now for sleep, they are called the sedative hypnotics. There was the older versions, and now there's the newer versions. The newer versions you probably know about, things like Ambien, Lunesta, Sonata, etc. They all, however, target the same receptor in the brain, which is called the GABA receptor, and so all of those drugs are still sedating drugs. And people mistake the former for sleep, the latter, and those two things aren't the same. So firstly, the initial point is, when you take those drugs, you are not getting naturalistic sleep, unfortunately. If I were to show you your electrical signature when you are on those drugs, it's not the same. The second issue with those drugs is that, as I said, they've been associated with a significantly higher risk of death. Part of that seems to be due to a disruption of the immune system. People seem to suffer far higher rates of infection when they're using those drugs. The third aspect is that they seem to be strongly related to cancer. Now, we don't have the causal studies there in terms of their carcinogenic impact. In fact, the FDA has currently suggested that it may be difficult to do those studies because the weight of evidence, the strength of the association, may actually make it ethically not viable to do those studies. That's how powerful it is. And those drugs are being taken in large amounts. In the last month, 10 million Americans alone have swallowed some kind of sleep aid. To put also the context around this, it took George Lucas about 40 years to amass $4 billion in profit in the Star Wars franchise. It took Ambien 24 months to accomplish that.
Hi, thank you so much again for your talk. It was really insightful.
Oh, thank you.
As a fellow student, I feel that we weren't exactly surprised by what we learned here today because we experience it every day. It's very rare that any student that I know gets over 7 hours of sleep. And I'm a college student. Imagine what high school students are going through right now.
Yeah.
But I guess the main question that I have is, what can we do to convince schools that sleep actually matters and that students aren't being lazy? Because you mentioned the 7:15, the 7:25 time. I suspect that the reason for that is because the schools usually use one fleet of buses.
Yeah.
And that's just cheaper.
That's
like,
right.
How do you even argue with that?
So I think, it is a non-trivial challenge to transport large numbers of individuals to a place such as a school at the same time. And I'm not trying to trivialize that. I think it's a really hard problem to solve. But what I would say is that, we've actually put people on the moon. So I think it's also still a solvable challenge. And I don't think, having a bus union and having some set schedule is a good enough excuse to compromise the brains and the development of the brains and the mental health and the physical health of our next generation because of that. I truly don't. Now, I think it's not easy just because of buses. It's also because of parents needing to get to work at a certain time. So it's actually a Herculean challenge. It's actually much more complex than it would appear on the surface. But again, I have to imagine that there can be some solution that we can come up with. Delaying school start times, new ways of transportation, you know, it's solvable. And we should be able to get there. And I think the data now is overwhelming. Oh, there shouldn't be but I don't want that. Please don't buy the, well, you don't need to read the book. I don't know why that's there. Well, actually, you just need to buy it. You don't need to read it. That's the, and if you can find an unsigned copy, it's probably worth a fortune. So I think, I truly believe that we will look back in 20 years' time with some degree of shame on what we were doing with this early model of school start times. And I think we will have those solutions then. And by the way, if you're worried about the financial cost of trying to increase the number of buses or even just do some kind of alternative transport, the model pays for itself in at least two ways. Firstly, the increase in grade performance in terms of the benefit for the economy and jobs is astronomical. And the Rand Corporation, an independent survey company, has actually scaled this out, and all of the data is there, and it's very impressive. Secondly, when kids go to school later, they come out the other end later. There is a period of time called the bewitching hour for crime, which is when kids get out of school, but before their parents get home, and they are unbuckled from a parental advisory role. That's where most juvenile crime typically spikes. Well, we would avoid that spike by later school start times, and the savings by way of that alone for crime would pay for the extra bus services. So you can't tell me that it's financially too expensive. That just doesn't work as a response.
Thank you.
You're welcome.
Hi, thank you for the excellent talk. I have a question that's slightly cheeky, but I also have a massive sleep deficit, so you can put it down to mental illness. I was wondering how many hours of sleep you get on average every night, and how you balance your work, because you're clearly quite very, very productive, and you do a lot. So how do you do it?
So don't rush to judgment on the latter. It's just because I have wonderful students and people at the Sleep Center. I give myself a non-negotiable 8-hour opportunity every night, and I say that not because I want to be some kind of poster child for the cause. I am on a mission to some degree, but that's not the reason I give myself that time. If you knew the evidence as I do regarding disease and sickness that comes by way of insufficient sleep, you would choose to do nothing other than that. It's a purely selfish act on my behalf. My family, for example, has a very strong history of cardiovascular disease. And deep sleep is the very best blood pressure medication that you could ever wish for. So I don't want a shorter life, and I don't want a shorter life that is filled with disease. I want a longer life, but I also want a longer, not just lifespan, but health span. And the very best health insurance policy that's largely democratic, mostly freely available, and for the most part painless, is this thing called an 8-hour night of sleep.
That's really great. Thank you.
You're welcome.
Hello.
I think I've got just one more question either side. I'm so sorry, and then I'll take others afterwards.
Thank you so much for your great talk.
Thank you.
So I'm an undergraduate student who actually sleeps 8 hours a night.
Congratulations, well done.
And so I was wondering about deep sleep and the sleep spindles that you mentioned, because I've been tracking my sleep for the past 3 months, and I've noticed that my deep sleep percentage is like between 14 and 17%. So I really want to know, like, what is, REM and light sleep have to do with the whole memory consolidation, and whether it's only deep sleep that the one that has all the benefits.
Yeah, so if you're sort of averaging around sort of 14%, you should definitely go to the hospital right away, and I'll stop answering the question. No, I'm kidding you. So firstly, what are you using to track your sleep? What device?
Fitbit.
Fitbit, yeah. So right now, the accuracy of these devices, and I'm wearing an Oura Ring, the accuracy of these devices is just not there yet in terms of separating out your deep sleep from your light sleep from your REM sleep. So I wouldn't try to get too concerned about that. There's something called orthosomnia, which is a new disorder where people are getting sort of a bit hyper-attentive to their sleep by way of trackers. I know, can you believe it? Ortho from the Greek origin meaning straightening. That's why you'd probably think of orthopedics, it's about straightening bones. And somnia being sleep, so it's about getting your sleep perfect and straight. And, so I wouldn't worry about that too much. What I would come back to is your question about which is the best type of sleep, as it were, to get. What should I worry about? It took Mother Nature 3.6 million years to put this collection and constellation of different sleep stages in place. What we have discovered is that every single stage of sleep is important. There isn't one that's more important than the other. They serve complementary but different functions at different times of night. But to suggest that any one of them may be more beneficial than the other is probably, I mean, if that was true, I suspect Mother Nature would have excised the weakling of the sleep bunch long ago, and the fact that they are still there tells you that you still need all of them, I suspect. So keep sleeping your 8 hours. I know that you said ever since you turned 60, you've been sleeping 8 hours, and it's working out for you very well. So
thank you so much.
Thank you. I think I've just got one more question, maybe. Sorry.
Thank you very much for your informative and inspirational talk. So according to some historic literatures, humans sleep in 2 shifts before the invention of the nightlight source.
Yeah.
So my question is how this type of sleeping behavior may influence the quality of our sleep.
Yeah, so some of you may have heard of this thing called first sleep and second sleep. Where people would sort of have about 3 or 4 hours at the first half, then they would wake up, they would socialize, music, food, people would make love, 3-hour gap, and then they would go back to bed again for another sort of 3 or 4 hours. Certainly it was a practice that happened. It was during the Dickensian era. Is that how we were designed to sleep? No, it doesn't seem to be that way. If you look at your biology, there's nothing suggesting that that's how we should sleep. However, should we be sleeping the way we do sleep in modernity, which is what we call monophasically? And the answer seems to be maybe not either. Because if you study hunter-gatherer tribes, and we've sort of looked at some of this work too, where their way of life has not changed for thousands of years, they don't sleep the way that we do. They sleep biphasically, where they have about 6.5 hours at night and then about an hour in the afternoon, a siesta-like behavior. And in fact, you're all programmed to do this. It's that afternoon lull where you get the sort of the head bobs. Like, it's got nothing to do with lunch, by the way. I can take away your lunch and you still have this pre-programmed drop in your alertness. It's not people listening to good music. It's just you're falling prey to what's called the postprandial dip. It's genetically enforced. It's hardwired. Everyone seems to have it. The argument is that we should be sleeping biphasically. So how we are sleeping in terms of the bouts seems to have changed with modernity, but also the timing. If you look at those hunter-gatherer tribes for their nighttime period of sleep, they are not sleeping when we are sleeping. Have you ever wondered what the term midnight actually means? Middle of the night. Now, midnight in first world nations has now become typically the last time that we check Facebook or we think about the emails or, but for those individuals, that's actually the middle of their sleep cycle. That's the middle of the solar cycle and their sleep cycle as well. So modernity has distorted how we sleep, both in terms of bouts, the amount of sleep that we're getting, and the timing of our sleep on the 24-hour clock face. I think I should stop. Thank you so much again. Thank you.